Namaskar, my dear friends. Welcome to the lecture series of Computer-Aided Manufacturing, 7th semester Mechanical Engineering. Okay, now let us first in this subject, which are the different topics that you have to learn during the semester. So, as per the syllabus of the Gujarat Technological University, the different topics in these subjects are Unit number 1 is the computer-aided manufacturing, in which we will learn about the meaning of CAM, scope of CAM, evolution of CAM, and computer integrated manufacturing. Unit number 2 is the NC CNC machine tools, in which we will learn about the NC, CNC, DNC machine and the different part programming of CNC machines. Then unit number 3 is the programmable logic controllers. It is known as PLC. Then unit number 4 is the group technology and CAPP, that means the computer aided process planning, in which you will learn about the different coding systems of group technology. Then unit number 5 is the flexible manufacturing system. It is known as FMS. Then unit number 6 is a robot technology, in which you will learn the fundamental of robots, different types of the robot and different technology used in the robotics. Then unit number 7 is the integrated production management system, IPMS, in which you will learn about the PPC, production planning control, MRP1, MRP2, just-in-time scheduling, different. Okay, so these are the different units that you have to learn in this subject, computer-aided manufacturing. Now, in the unit number 1, computer-aided manufacturing. Okay, so different contents you have to learn in this lecture. That is the industrial revolution, introduction of CAM, objectives of CAM, scope of CAM, and computer integrated manufacturing. Okay, before starting this first unit, industrial revolution, let us see one video.
Industrial Revolution, 18th to 19th century. The economic developments of the 1800s saw the development of agrarian and handicraft economies in Europe and America transform into industrial urbanized ones. The term to describe this phenomenon would be known as the Industrial Revolution and was first used by French writers but made popular by English economic historian Arnold Toynbee. The Industrial Revolution was underpinned by the Agricultural Revolution. From the mid-18th century to the mid-19th century, agricultural production increased significantly. The huge increase in food output supported the expansion and sustained a large population and boosted trade. The increased use of machines over human or animal power in farming also meant that less farm workers were needed, and they could leave the land to industrial towns. Better metals and richer fuel also contributed to industrialization by creating the steam engine, an integral machine to industrialization which powered factories, locomotives, and ships. The new steam engines used coal and iron, both in their construction and as fuel, increasing demand for these resources. Roads, canals, and railways changed Britain dramatically, connecting Britain and allowing goods to be sent over long distances. Visually, the revolution was clear in the new industrial towns, with smoking factories dominating the skyline. The cities were horrible to live in, overcrowded and dirty with dangerous conditions in the factories and strict rules and punishments. The Industrial Revolution saw mechanization in factories of the textile industry, which was previously manufactured in the home, creating the term cottage industry. Now, production could be increased on a large scale because of new inventions such as the spinning mule and the power loom. The iron industry developed with Henry Bessemer's inexpensive process for mass-producing steel. Iron and steel were key materials for constructing the tools and machinery, steam engines, and ships needed for the industrial progress. Industrial labor opportunities drew people to the cities from the countryside, to such an extent that in 1750 only 15% of the population of Britain lived in towns. By 1850, Over 50% of the entire population of Great Britain lived in either a town or a city, and by 1900, it was 85%. London had 4.5 million people, Glasgow 760,000, Liverpool 685,000, and Manchester and Birmingham 500,000. Great Britain was the birthplace of the Industrial Revolution and was the only mature industrial economy for a long time. Historians have speculated that this was because, as an island, there was relative peace and stability for Britain compared to mainland Europe. Rather than spending on a large defensive standing army, capital could be spent on other ventures, and there was confidence for investors. Native resources were also abundant and readily available for initial technological developments and inventions. Engineers and inventors were also respected and encouraged in British society and were backed by wealthy patrons. A powerful navy and an empire bringing in vast wealth from its colonies also contributed to the catalyst for industrialization before others. Nevertheless, Germany, France, Switzerland, Belgium, and the United States soon emulated Britain's industrial change, and by 1900, Britain would no longer be at the top, with the United States as the world's leading industrial nation in the 20th century.
Industrial Revolution. Now, here you can see on the 18th of century, that is, it is known as the Industry 1.0. In this revolution, it was based on the mechanical production equipment and it was driven by the water and steam power. Okay, so during that, it brought the mechanical innovation such as the steam engine, cotton spinning, and railroads. Okay, now in the 19th century, it is known as the Industry 2.0. Okay, so it was based on the mass production and it was enabled by electrical energy. So electrical energy was introduced in the Industry 2.0 in the 19th century, and it was division of labor. So brought light bulbs, telephones, and the assembly lines. Okay, so during the mid of this or 20th, 19th century, okay, or we can say in the 1969, the Industry 3.0 was introduced, and during that, based on the electronics and information technologies to further automate the production system. Okay, so in which the computer was introduced in the industry, that was the mainframe computers, and personal computing and the internet was introduced in the Industry 3.0. Nowadays, the Industry 4.0 is introduced and the latest system is used in the industry. So in which the based on the cyber physical system brought 3D printing, okay, big data, and the Internet of Things. So different technologies are now is a necessity for the industries. So in this way, the different revolutions are made in the industries. Now, introduction of computer-aided manufacturing. Meaning of CAM. So, computer-aided manufacturing is an application technology that uses the computer software and machinery to facilitate and automate the manufacturing process. So, CAM is the successor of computer-aided engineering and is often used in the tandem with computer-aided design, right? So in computer-aided manufacturing is the use of software to control machine tools and related ones in the manufacturing of workpiece. This is not the only definition of CAM, but it is the most common, and CAM may also refer to the use of computer to assist in all operations of a manufacturing plant, including planning, management, transportation, and storage. So its primary purpose is to create a faster production process and components and tooling with more precise dimensions and material consistency. Okay. So which is in some cases uses only the required amount of raw material. Okay, so thus it means it minimizes the waste while simultaneously reducing the energy consumption. CAM is now a system used in the school and the lower educational purpose also. CAM is a subsequent computer-aided process after computer-aided design and sometimes computer-aided engineering. So, as the model generated in CAD and verified in CAE, that is computer-aided engineering, it can be input into the CAM software and which then controls the machine tool. So, CAM is used in many industries, okay, or we can say the school is alongside the computer aided design to create the different object, right? So the use of computer system to plan, manage and control the manufacturing operations, direct or indirect computer interface with the plant's production resources. Okay, so this is computer aided manufacturing. Now, computer aided engineering. Computer aided engineering, it means the use of computer system to analyze the CAD geometry. Okay, whatever the model we prepare in the computer aided design software or the CAD software, that software, that models, it will be analyzed in this computer aided engineering. So this CAE, it allows the designer to simulate and study how the product will behave, okay, or allowing for the optimization. Finite element method, FEM. Okay, so it divides the model into the interconnected element and simultaneously solves the continuous field problem. So this is known as the CAE, computer aided engineering. Now, objectives of the CAM. Different objectives of the CAMs are the use of computers to guide the working of the industrial processes is known as a computer-aided manufacturing or CAM. Any factory can be made highly automated by deploying real-time systems and robotics. A CAM system is highly efficient because it can control the production house through different automated techniques. The purpose of CAM is to ensure that the error rate is decreased, uniformity of product is high, and precision in the process can be achieved. CAM operations is part of now almost all industries. It is useful in removing errors from the primary manufacturing processes and can also keep track of further orders and materials to be used. The automated plants have provided a hygiene and a clean environment to various processes which cannot be achieved fully by manual processes. The processes are now fully automated and that they can replace the tools and switch to successive processes on their own. So the use of computers to guide the working of the industrial processes, okay, is known as we know is CAM. So any factory can be made highly automated by deploying real-time systems and robotics. CAM system is highly efficient because it can control the production houses through the different automated techniques. Okay, so these are the different objectives of computer-aided manufacturing, or we can say CAM. Now, the scope of CAM, right? So here in this circle, you can see in the middle or in the center is the factory operations and the different department, that is the design, manufacturing, planning, manufacturing control, business functions. Okay, so what are the scope that is integrated, that CAD, CAM, CAE software like the Pro Engineers, Ideas and Kitias. Okay, the numbers of CAD, CAM, CAE softwares, they help the manufacturers to optimize the product concept only in design process, enabling them to significantly improve the product quality, okay, while reducing the product development time and cost. And moreover, the people having the 3D CAD CAM CAE knowledge have the better chances of growth and immediate employability after the completion of course. Okay, so graduation and the chances of job abroad. Okay, so number of scopes of CAMs are there. Now, as the market economy opens more and more, it has become extremely competitive and with this state of economy. Skilled people play the most important role in organization as it becomes imperative on the part of top tool room and training centers and engineering. Okay, so an emerging trends of this engineering education in tool room and the world is the rapid incrementation of CAD CAM CA software as an essential part of our curriculum. So we can say there are numbers of scopes nowadays in computer aided manufacturing. This computer aided manufacturing, it includes the use of CAD files. Okay, so different steps you can see here. Define the machine tool that will process the part, define the stock or material, define the features to machine, generate operations, select the origin, generate tool path, simulate tool path, generate NC code, download NC programs, and operate the CNC machine that will cut the part. Okay, so this is the procedure of how to generate any job or a part from CAD file to the CAM. Now, role of management in CAM. Now, in the modern world, rapid changes and global expansion results in the changing of business organizational trend. Okay. Business transactions that had been done traditionally are no longer sufficient. Okay. So, new methods has to be introduced to meet the consumers to cope with current market demands. Therefore, the business process re-engineering, it is known as the BPR, that has been introduced since the 1990s and are used worldwide nowadays. So with the addition of information system and technology, now it can help to improve the main business processes in terms of communication, inventory management, data management, management information systems, customer and relationship management, that is CRM, computer aided design, computer aided manufacturing, and computer aided engineering. Okay, so the role of IT in a business process within area of CRM, communication, information management, and inventory management to boost the efficiency and effectively a BPR adoption. Okay, so the role of management in CAM is very important. Okay. Now, let us move toward the computer integrated manufacturing. What is the meaning of the computer integrated manufacturing? The different persons have given the different definition. And now, let us see. One needs to think of SIM as a computer system in which the peripherals, instead of being printers, plotters, terminals, and memory disks, are robots, machine tools, and other processing equipment. So it is a little noisier and a little messier, but it's basically a computer system. This definition was given by the Joel Goldhar, okay, Dean of the Illinois Institute of Technology. Then, as per the Dan Appleton, that is president of DACOM, SIM is a management philosophy, not a turnkey computer product. It is a philosophy crucial to the survival of most manufacturers because it provides the levels of product design and production control and shop flexibility to compete in future domestic and international markets. The Charles Savage, the president of Savage Associate, he gives the definition: SIM is an opportunity for realigning your two most fundamental resources, that is the people and technology. Okay, so it is the opportunity for realizing the two most fundamental resources, that is the people and technology. So it integrates the people and technology. The same, it integrates the people and technology. Or one more definition given by SIM is a lot more than the integration of mechanical, electrical, and even informational system. It's an understanding of new way to manage. So as per this definition, it gave integration of mechanical, electrical, and even the informational system. Okay, or we can say understanding of the new way of manage. Jack Conaway, that the SIM marketing manager, he gives the SIM is nothing but a data management and networking problem. Okay, so these are the different definitions given by the different persons. So in short, we can say the term SIM or the computer integrated manufacturing, it comprises the three words. These are computers, integrated, and manufacturing. These are the three words, okay? So though all the three words are equally significant, the first, that is the computer and integrated, are secondary and merely adjectives. This modifying the last one, that is the manufacturing. So SIM is the application of computers in manufacturing in an integrated way. So all types of computers, from personal computer to the mainframe, or maybe using SIM. The middle term, that is the integrated, it's the most important terms in SIM, is very appropriate. It brings home the point that integrated of all the resources, that is the capital, human, technology, and equipment, is vital to success in manufacturing. Okay, so implicitly, SIM discourage any haphazardous applications of computers and other technologies that results in the isolated island of automation. So integration is achieved through timely and effective communication, which SIM relies on heavily. Since the computer is the basics of integration, communication within the context of SIM is strongly computer oriented. Now, computers and computer communications have been with us since the 1950s. So SIM is relatively new. It began to draw the attention only in the 1980s. Why this late? For two reasons. First is, until recently, computers had been too expensive to be cost effective in manufacturing. And only business functions such as accounting and payroll and some external inventory management could satisfy the high cost. The low cost and improved capabilities of today's computer system have changed that. And the second reason for the delayed birth of SIM and its slow progress is the sheer complexity of integration arising from the large number of tasks that interact in discrete manufacturing in today's sophisticated market. So integrated manufacturing by itself is not a new concept, but SIM, which orchestrates the factors of production and its management. SIM is an umbrella. SIM is an umbrella term under which all functions of manufacturing associated acronyms such as computer-aided design and computer-aided manufacturing, flexible manufacturing system, and computer-aided process planning, CAPP, okay, find a place. Discrete manufacturing has always presented a challenges because of the large number of factors involved and their interaction. So SIM is being projected as a panacea for this type of industry, which produce 40% of all goods, process industries where volume is high enough to justify hard or dedicated automation and may also benefit from SIM. Okay, so the meanings of the different definitions that we have discussed. Okay, now what are the benefits of SIM? So there are two types of the benefits: tangible benefits and intangible benefits. Now let us see what are the tangible benefits. Higher profit. Okay, directly we can get more profit. Less direct labor. Okay, use of labor is reduced, so less direct labor. Increase machine use. Okay, by implementing this SIM, we can increase the machine use, or we can say minimize the ideal time of the machine. Reduce scrap and rework. Okay, we are using the use of computer in this. Okay, so we can reduce the scrap and rework, and we can minimize the rejection. Increase the factory capacity. Reduce inventory. Shorten the new product development time. Fewer missed delivery dates, or we can say we can produce the product in time. Okay, so fewer miss the delivery date. We can decrease the warranty cost. Now some intangible benefits are there. Higher employee morale. It can higher the employee's morale. Safer working environment. Improve customer image. Greater scheduling flexibility. Greater ease in recruiting new employees. Increase job security. More opportunities for upgrading the skill. So these are the different tangible and intangible benefits of the SIM. Okay, so now let's stop here, and in our next lecture we will learn about the SIM wheel and different types of the production, evolutions of SIM, okay, then types of manufacturing systems and mass production, okay, of then role of management in SIM. So I hope you can understand very well. Thank you very much, friend. Thank you.